In this video, we're going to introduce a very useful technique to find areas. And the technique is called find area by decomposition. The idea is to find some area of an irregular shape. It's often useful to calculate areas of the other shapes. And subtracting the other shapes from the total area, you get the area of this irregular shape. So let's look at one example. Look at this figure on the left. We have a square, 4 by 4. It's a 4 by 4 square. And we have the 2 points A and B. A is with a length from, let's say this original point is 1, and this B point is on this side, a length of 2, and then connect with this point of C. We want to find the area of this triangle ABC. How we do that? Now, we know that the area of a triangle, the formula for that is if we find a base, fix a base, let's say fix base AC, we need to find the height correspond to AC. And the area of a triangle equals half of base times height. Of course, the base can be AC or BC or AB. But look at this figure. None of that is easy to calculate for the height. Of course, that the base is not so difficult because if you know Pythagorean theorem, the AC is just the hypotenuse of this right angle triangle, right? So you can calculate AC. Similarly, you can calculate BC and you can calculate AB as well. But the height for any of them is not so easy. You have to calculate this height. So this looks like a tough problem. But looking at a different light, you see that this triangle is just this square subtracting those 3 right angle triangles. A different way of saying it is the total area of this square, the area of square equals this area, let's call this area S1, this right angle triangle equals S1 plus, let's call this S2, this is 3, and this S is the one that we want to calculate. 2 plus S3 plus S. These 4 shapes makes up this square. That's why you have the total area of the square equals S1 plus S2 plus S3 plus S. Now look at S1. This is a right angle triangle, so it can be easily calculated, the area. Similarly for S2 and for S3. So after you calculate S1, S2, S3, by subtracting those from the area of the square, you get S, correct? So this is the technique called find area by decomposition, and implicitly by doing subtraction. So the S of the shaded area, or the S triangle ABC, is going to be the total area of the square, which is 4 times 4, minus S1 plus S2 plus S3. What's S1? S1 equals, for this right angle triangle, you have the 2 legs, 2 and the 4. So S1 equals 2 times 4 divided by 2 equals 4. S2 equals, the S3 is this right angle triangle with the 2 legs, 2 and 1. So 1 times 2 divided by 2 equals 1. S3 equals, it's a 3 by 4 right angle triangle, so 3 times 4 divided by 2 equals 6. So In here, we plug in S1, S2, S3 equals 16 minus 11 equals 5. And the unit of this area, again, it will be unit squared because you have the product of two sides for area equals 5. Let's look at another example of using this technique of find area by decomposition. This problem, let's say you have a garden, a square garden of 10 meter by 10 meter. And you want to make a brick board with width 1 meter around this garden. So on the four sides of the garden. Make a boardwalk like this. Okay, I'm not drawing completely proportionally, but this is 10 by 10, but in here, each side is 1 meter. What is the area of this boardwalk? Now, of course, you can calculate this area by doing a decompose this one by a bunch of rectangles. For example, you can calculate the area of this rectangle plus the area of this rectangle, and then plus the rectangle of these two rectangles. Just be careful that you don't want to overlap, right? Because all the corners are overlapped. So you can do that way. A different way, if you find area by decomposition by doing subtraction, is realize this boardwalk is just the whole area of this big square minus the area of the square inside. So the area we want to find out is equal the area of the big square, which is 10 by 10, minus the area of the small square inside, which is 8 by 8. Okay, why this is 8? Because this is 10 minus the two sides 1 meter. So this is 8 meter. And this equals 36 square meters. So in here, I'm using two very simple examples to illustrate the idea of finding area by decomposition. This technique can be used in many, many different scenarios. Anywhere that you see that to find the area of some irregular shape, always look out for the way of using decomposition and find areas of the rest shapes, which hopefully are much simpler to calculate.